Hello and welcome back to part 2 of the lesson on earned value analysis, where we are discussing the advanced tools, techniques and methodologies that you need to understand in order to pass your exam. I'm your instructor, Cornelius Fichtner. This is the second of a 3-part lesson on earned value analysis here on the Project Management PrepCast. In part 1, we went through an introduction to earned value with some history on where the earned value methodology came from and an exciting discussion on building houses to understand variances. In part 2 right now, we cover indices and forecasting, and then in part 3 we will discuss the estimate to complete as well as the to complete performance index. We'll also look at various miscellaneous formulas. None of this discussion is talking about chump change. So, ladies and gentlemen, start your calculators. A reasonable question for your stakeholders to ask is whether the project is efficiently using time and resources. Are you facing different challenges that affect your performance? Perhaps it's bad weather, a delay in procuring resources, or lack of training or experience with a particular process or tool. You may notice that when we mentioned performance, we did not ask if you are working fast, and it's not necessarily about speed here. Working too fast can make your work error-prone, which often results in work being repeated or consuming more resources. As a project manager, you are always balancing time or cost versus quality. Overall, when we talk about performance, we are trying to balance scope, cost, schedule, and quality as they are interrelated. You need a way to measure performance, and earned value accommodates that by what is called an index or indices, because there are a couple of them. They help you better understand if you are achieving the planned performance levels. These indices are more useful than variance values in identifying trends and relative performance between projects. Over the next few minutes, we discuss these different indices, starting with a new example to set the stage. To better understand indices, we are awarding your family with an all-expenses-paid hypothetical vacation to Japan. You and your family are in Tokyo, that is on the right of the map that you see here on the screen, and you are ready to start the day driving to Osaka, that is the point on the left. The distance is about 500 kilometers. You are sure that you can drive at 80 kilometers per hour for the trip, and doing the math, you expect that the drive should take you around 6.25 hours. You get everyone up and you have breakfast so that you can leave Tokyo at 8 o'clock in the morning. That gets you to Osaka around 2:15 in the afternoon, with plenty of time to do some sightseeing before dinner, theoretically. Although you plan on driving 320 kilometers by noon, you check the odometer and, to your disappointment, it says that you have only covered 250 kilometers. You could now figure out your percentage complete by taking the mileage you have driven, 250 kilometers, divided by 320 kilometers and multiply that by 100, and you get 78% of the distance that you had expected to drive. You can now use this to judge your progress and determine if you need to take corrective action or need to change plans as you are late. You can apply the same concept to our house building project that we introduced you to in part 1. In that example, we could look at week 14 differently. At that point in time, our earned value was €400,000 because we had not completed the foundation as planned. However, we had actually spent €420,000. Using the same logic as in our driving example, we are only 95% of where the expenditures say we should be. But in earned value management, we do not use percentages for this measurement. We use raw ratios without multiplying by 100. We call this the Cost Performance Index, or CPI, which in technical terms is earned value divided by actual cost, and in this case the CPI comes out to 0.95. CPI is used as a measure of how efficiently we are spending our money. Another way of looking at the CPI is that for every euro spent, we are only getting 95 cents worth of productivity. The same is true for our scheduled performance. The Scheduled Performance Index, the SPI, is earned value divided by planned value. It is a measure of how efficiently we are using time on a project. In our housing example, the SPI is 400,000 euro divided by 430,000 euro, or 0.93. This says that our team needs to work 100 hours in order to achieve 93 hours of work. And notice in particular here that we are talking about hours and not euros. All right. This is all great, but what do I do with these two indices now that I have them? Well, besides telling us where we are at, earned value analysis helps us create forecasts. Most of us are familiar with forecasting. I'm sure everyone has seen a weather forecast, and even though many weather forecasts seem like, they're guessing, there is actual science behind it. In project management, people are involved, so there is also a lot of art in forecasting. So, a forecast is an estimate or prediction of conditions and events in the project's future based on information and knowledge available at the time of the forecast. You should already note that with words such as estimate, prediction, and future, forecasts are not 100% certain. They are approximations based on assumptions and our knowledge at the time of making the forecast. Forecasting is needed since not all projects run as planned. In fact, most projects don't run as planned, right? So you and your stakeholders are going to want to know what it is going to take in order to finish the project. And don't get me wrong, although many projects are late, some are actually performing better than planned, and the same question needs answers. Specifically, what is the expected total cost of the project? What is the expected cost to complete and the remaining work, as well as can we make the forecast? What is the performance required with the existing resources to deliver the project as promised? Earned value has a series of formulas to help you answer these questions. The best place to start is understanding how to determine the final cost of a project that is not performing to plan. Earned value uses the term estimate at completion for this. The estimate at completion, or EAC, is today's forecasted estimate for the total cost of the project when it is complete. But it remains an estimate until you decide on a new approach and then also get appropriate stakeholder approval and sign-off on the change to the budget at completion, or BAC. Determining a new EAC helps you understand what the new BAC might need to be. This process answers the question, am I still on budget? And if not, what is the new cost of the project? But in truth, the answer to these questions is, it depends. In coming up with the estimate at completion, you have different options of how to forecast based on the situation that you find yourself in on the project. And we look at 4 scenarios, which we do in 3 phases. The first pass is to familiarize you with what the scenarios are all about. The second is to discuss the formulas. And finally, in the third pass, we see how they fit into our housing project. So let's start with the first pass here. Now remember, we are trying to create a new estimate at completion, and we are starting with scenario A. In scenario A, you use this model if you have no trust whatsoever in your original estimates anymore. Therefore, your CPI as well as your SPI are not trustworthy. This means that all the red circles that you see here are like a stoplight, Maybe the assumptions on which the original estimates were based are no longer true and do no longer apply, or the original estimate is fundamentally flawed, perhaps due to poor estimation techniques. Your only real option here is to re-estimate the rest of the project. Re-estimation takes time and probably adds more cost to the project as a result. But since you don't trust in anything that you have, that's where you have to go. And then there is scenario B. You use this method in scenario B if you think that the difficulties and the differences incurred on the project are only transient. They will go away again. Maybe a problem that you planned for never materialized and you are ahead of schedule. Or you had some difficulties in the first part of the project, but they are in the past and will not affect your estimates in the future. You can use the planned estimates for the rest of the project. Therefore, you accept the original estimates, but not the current CPI and SPI. You feel that the CPI and SPI going forward will be close to 1, saying that you are tracking original estimates. For example, you know that you are over budget because 3 of your engineers were sick with a cold for 10 days last month. That's why your numbers are off. But now that the flu season is over, you don't expect to have such a major loss going forward. In the third scenario, you feel happy with the original estimates and feel that the current CPI will hold for the rest of the project, even though you may not be as happy with the value of the CPI. Therefore, you are comfortable using that CPI to determine where the project is going. This could be a result of a problem you thought would plague the project, say poor communication, and it hasn't happened. What a pleasant surprise. On the flip side, it could be that you planned for your software development team to travel to the client's site, and they have pushed back. They do not want to travel. This would cause more delays, as you have seen. Regardless, you expect the conditions that you are currently seeing to continue. The final scenario is D. Here you are concerned that the project is not performing as planned, but you trust in your original estimates and you are confident that the current CPI and the current SPI, no matter how bad they are, will continue. Therefore, we have 3 green circles. But you are not on budget, nor are you tracking to your schedule. So you need to produce a new EAC that considers the schedule and cost performance issues. To do this, you look at where you are on the project and you use the current indices to try and predict the potential outcomes. In calculating the estimate at completion, you want to make sure that you consider both the cost and schedule differences. And those were our 4 scenarios, and with that basic understanding out of the way, we can now dig deeper into each of these, looking at the formulas as well as how they affect our house building project. We start with scenario A. This is where we re-estimate the rest of the project. As I said earlier, in this scenario, you opt to re-estimate when you cannot rely on your original estimates. That's why we have the red circles. Maybe you have consulted with the experts or your stakeholders who arrived at the original estimates, and now they tell you that they want to revisit, revamp, or completely change their original baseline durations and cost for the rest of the project. They just don't trust the original estimate any longer. So this means we are now at a point where we have to calculate how much it's going to cost. That's why it is called an estimate to complete from here on forward. In terms of a formula, this implies that to arrive at an estimate at completion, you need to add your re-estimation to what you've spent so far, meaning that you add actual cost and your estimate to completion. That gives you the EAC. Again, use this formula for EAC if your original estimate was fundamentally flawed or conditions have changed and invalidated your original estimating assumptions. You use the bottom-up estimate to complete when you no longer trust your numbers. You need to re-evaluate everything from labor hours all the way through your different assumptions. For example, you must look at each task and figure out the cost by multiplying the labor rate by hours. Look at each resource, double-check its need and cost, and then look at special conditions that might have added to the errors. Maybe you did not judge productivity of the workforce right, or current exchange rates are fluctuating rapidly, or there has been a natural disaster that affected the project, or a multitude of any other condition. Think back to a housing project. Maybe a new highway project has created a shortage of cement and changed the foundation's cost. You then add these numbers together for a new estimate, just like you did in estimate cost, except you are doing it just for the last part of the project that is not yet complete. There are, of course, a number of problems with this bottom-up method. First, it takes time. As you know, the time that you and your team spend re-estimating the project is lost and can never be regained. Re-estimation is also costly. The time you spend is not the only thing lost. So it's the money paying people to do the work. Every hour that you or your team spend re-estimating is added to your project cost. That cost needs to be added to your new estimate as well. You may need to look at other ways that might be quicker and less expensive. This is where our other scenarios can help. If the reasons for our variance are behind us, then the formula for scenario B might be useful. Here we assume that we can accomplish the future work at the planned rate, even though we've had some difficulties in the past. To use this, you need to make two assumptions. First, the same problems will not reoccur, and second, you trust the future estimates. Therefore, you can see this single green circle under the original estimates column. This means that the current cost variance, CV, is going to stick with the project until the end, but the numbers in the future are correct. The EAC is the budget at completion because you trust the estimates minus the cost variance. It is subtracted because when you are over budget, the variance is negative, and if you are under budget, it is positive. The other and long form way of writing this is this formula here at the bottom. You can remember this formula because budget at completion minus earned value should simply be what was left to complete on your project, which includes the variance. And if you enjoy algebra, you can actually prove that the short formula at the top is the same as the long formula at the bottom. If, however, you feel that the original estimates are correct and the current conditions will continue, that means you feel good about using the current CPI. This is scenario C. Both the original estimates and CPI are green, as you are agreeing to use them even though you may not be happy with the value of the CPI. At the root, this means that you feel that there are one or more factors that are affecting the project and that they will continue to do so at the same magnitude. Maybe your team is just not as efficient as you expected, or maybe they are much better. Think back to the example of driving from Tokyo to Osaka. It would be equivalent to being on that drive saying, look, for the last 4 hours we have been driving at 63 kilometers per hour, not 80. I see no reason why that is going to change. So you use the prior CPI value, the 63 kilometers per hour, because you cannot see that conditions are going to be changing. The formula to use is estimate at completion is budget at completion divided by CPI. In this particular scenario, we ignore the SPI. It is not considered. And then our last scenario, scenario D, looks at this alphabet soup of a formula here. It is truly the most arcane, but it is very useful when your project has multiple issues. There are a lot of green circles here in this table, and even though you may not be happy about the condition of the project, those green circles say that you think the original estimates were sound and that the current CPI and SPI both reflect a reality that you have to live with. No need to cry over spilled milk. Admit the faults and move on. It assumes that your planning was correct, but that a series of unplanned events are affecting the cost and schedule. It is the only formula that uses the Schedule Performance Index. Therefore, if the schedule is a factor as well as cost, this formula is to be used. A warning is that this formula is very sensitive to the CPI and SPI, and the farther away they get from 1.0, the greater their effect. So, there are a lot of formulas we can use to try and figure out the estimate at completion, and even though we have given reasons behind when to use each one, what do they really do? To understand that, it makes sense to go back to our house building project from earlier. It is in week 14 with an earned value of €400,000, an actual cost of €120,000, and a budget at completion of €1.2 million. For scenario A, the bottom-up estimation technique, we decide to hire a consultant for a week to do the numbers and make recommendations. He costs €29,500. He thinks that you can schedule some overtime to recover from the schedule slip on the one foundation, and that the other cost estimates are still good, because we have witnessed this with the first two houses. They finished on time. The overtime would cost you €7,800, and the added time that your team spent talking to the expert was €2,000. The total extra cost is therefore €39,300. This means that the new estimate at completion is the actual cost at $420, plus the remaining work of $780, plus the additional cost of $39,300. That gives us a total of €1,239,300. If we choose scenario B, we say that the problems from the past are the past and will not happen in the future. This estimate and completion equation includes the cost variance, so we need to calculate it out first. The cost variance is earned value minus actual cost. That is €400,000 minus €420,000, which equals minus €20,000. The estimate at completion is simply budget at completion, which is $1.2 million, minus the cost variance, or, well, €1,220,000. Or using the other form of the equation, actual cost plus budget at completion minus earned value, that gives us $420,000 plus $1.2 million minus $400,000 equals €1,220,000. As you can see, either equation, short form or long form, gives the same answer. Which one you use depends on which is easier for you to remember or which numbers are provided to you. In scenario C, we accept our original estimate, and we also accept the fact that the CPI, the Cost Performance Index, will continue going forward. Therefore, the estimate at completion equals the budget at completion divided by the CPI, where the CPI is earned value divided by the actual cost. So when you do the math to calculate for the EAC, it works out to be BAC divided by EV divided by AC in parentheses, which works out to be 1.2 million divided by 400,000 divided by 420,000, or the estimate at completion here would be 1.26 million. This number is a lot higher than the prior two scenarios. That makes sense because this assumes that the cost performance issues will continue. We will continue to be over budget. That might be the case if we continue to see issues with the foundations, but our experts think we won't. So this may not be the best formula to use anyway. Lastly, we have scenario D. That's our alphabet soup formula where EAC equals the actual cost plus BAC minus earned value divided by CPI times SPI. In that equation, we know that SPI is earned value divided by planned value and that CPI is earned value divided by actual cost, respectively. When we plug in the values and get our calculator working, we get 1.323 million. Wow, that's 103,000 more than scenario B. That's a lot of pizza and beer for our construction crew. Again, this makes sense because this formula assumes that there are multiple factors that are affecting both the cost and schedule performance, and so the estimate at completion logically has to be the highest. As you have seen, this is a lot of work and it doesn't make sense to do all four calculations. You would obviously follow the scenario that makes the most sense in your particular project situation. In our house project, we only saw one house having problems. There is no information to say that the conditions would continue. Therefore, scenario B is our best choice in this particular situation. If, on the other hand, we had some indications that shows, well, the foundations for our future projects, for our future houses, they're also going to be delayed, then scenario C would make more sense for us and we would use scenario C. But lucky for us, the best choice in our case also happens to be the one with the lowest cost. Whew! Now that you're all cross-eyed and your calculator is smoking from all the numbers, it's time to take a break. As you might expect, there are a lot of takeaways from this lesson. 3 screens full of takeaways, in fact. Here we go. It would be nice to have some general rules to follow about indices, but there's really only one. Indices are always ratios between two numbers, like earned value divided by actual cost. It gives you the cost performance index, the CPI. Other rules are specific to the type of index. For the CPI and SPI, values that are less than 1.0 are bad. You are not using your money or time efficiently, and values greater than or equal to 1.0 are good. You are using your money or time efficiently. In part 3, we will be looking at the TCPI, the To Complete Performance Index. It has some different rules. It's also important to pull part 1 and 2 of this lesson together as a takeaway. The table you see here you have encountered in control costs. With what you have learned now, you should be able to actually build this table on your own. So why not at some point give it a try? Take out an empty piece of paper, draw the outlines of the table, and then fill it in. And finally, part 2 of this lesson focused on what to do if your variances indicate that the project is drifting away from the plan. There are 4 methods to determining the estimate at completion. Completely re-estimating the remaining project work. This can be time-consuming and costly. When you know that the condition causing the good or bad variance is temporary and will not reoccur, we can use the cost variance. When you determine that the conditions causing the variance will continue, we use the cost performance index, the CPI. And when there are multiple problems in scheduling and costing that are contributing to the condition, and you expect those issues to persist, we use both the CPI and the SPI in our formula. These aren't the only formulas that you need to know for the exam, but these are the most complex. Until next time.